Hello, good evening. This is Naz from NB Network Lessons. Welcome. This is Calculus 2 lesson. I already did a Calculus 1 lesson. It's in my collection, so you're more than welcome to go and explore it. But having said that, we're going to dive into Calculus lesson number 2. So this right here is a graph between position or distance and time. Okay. And this right here is a graph of velocity on y-axis and then time on x-axis. And then this is acceleration, which is basically same thing. On y-axis we have acceleration, and on the x-axis we have time. So basically in my last lecture I told you that I took two derivatives. So derivative of position is velocity. That's a known fact. And then derivative of velocity is acceleration. What is a derivative? Derivative is a rate of change. Okay, it's basically anything which is constant and it picks up speed and then keeps on accelerating. That is rate of change. Okay, how much distance are you covering per second? Okay, so there is a change. But if there is no change, okay, if everything is constant, then derivative is zero. It's a constant. Okay, so basically position, I said graph of position, graph of velocity, graph of acceleration. So now what I can do is I can say right here, if I want to write this derivative of this, I can say v function of t, function of time, is equal to derivative or p prime of t. Basically what I'm saying is that change in velocity as a function of time, right, based on change on position. So this is how I can write derivative. First derivative of velocity is basically p prime function of t. I can also write this as v t is equal to dp over function of t over dt. It's same thing. Okay, I can write this as p prime of t, or I can write this as dp function of t over dt. Okay, now when we come to the acceleration, remember I told you if you're going on a constant speed, okay, there is no acceleration, then your derivative is constant for acceleration. How do we write it? Well, we can write it by saying acceleration function of t is equal to v prime over t. Okay, or we can write this as dv function of t over dt. So how's that? So this right here is the derivative of velocity based on position. This right here is derivative of acceleration based on velocity. Okay, now I can also write this as p double prime means double derivative, is equal to p double prime t, or I can write this as d square pt over dt square. All right, so I just wanted to go over this today. I'll come back and we'll go ahead and do the lesson number 3. Thank you so much. Have a nice day. I'll see you next time. Take care. Bye-bye.